ladies and gentlemen, I want to take just a few minutes on this video to talk a little bit about atoms. Now, atoms are the basic building block in chemistry. They are the smallest possible particle of a substance that retains the property of that substance. Now, we do know that while they are the smallest possible particle that retains the properties of that substance, they are not the smallest possible particle. Atoms themselves are made up of smaller particles. We call those subatomic particles. And we're going to focus on three subatomic particles that make up atoms: protons, neutrons, and electrons. And in this video, we're really only going to focus on two, the two that are found in the nucleus, in the dense center part of the atom. Okay? Those are protons, which have a positive charge, and neutrons, which are neutral. The number of protons determines what type of atom it is. If you know how many protons an atom has, you know what kind of element it is. And we call that number of protons the atomic number. The atomic number, and we use the symbol Z for atomic number, is the number of protons in an atom. The reason we call that the atomic number is because it determines the type of atom. Now, while the number of protons tells us the type of atom, you can have different types of the same atom. They're the same atom, they have the same number of protons, they have the same chemical properties, but they're slightly different because they have a different weight or a different mass. And we call these isotopes. So isotopes are atoms of the same element that have different masses. The reason that they have different masses is because they have a different number of neutrons in their nucleus. The protons are the same, has to be the same in order to be the same type of atom. But if they have extra neutrons, that makes them heavier. If they have fewer neutrons, that makes them lighter. So an isotope is an atom of an element with a specific mass, which means it is an element that has a specific number of neutrons. So each element always has the same number of protons, the atomic number, but each isotope also has a specific number of neutrons. Now, if we take the number of protons and the number of neutrons and we combine them together, we call that the mass number. And the symbol we're going to use for mass number is capital A. Protons and neutrons together, since they're found in the nucleus, are also called nucleons. You may hear that term from time to time. So you could also say the mass number is the number of nucleons, which means it's the number of protons and neutrons combined. So make sure that you know that definition as well. And I now want to talk about how to write the symbol, not just for an atom, but for specific isotopes of atoms. The way we do that is we go to our periodic table and we find the chemical symbol for the atom. Now, none on the periodic table actually have the symbol X. This is just representing any symbol for an atom that we want to look at, the symbol for the element. That will always either be a one or two letter symbol that you'll put here to tell what kind of atom you're talking about. Then if you want to specify the type of isotope, at the top left you put the mass number. Remember that mass number is the number of protons and neutrons combined. Generally, we also put the atomic number at the bottom left. You really don't have to put this, because if you know the type of element, you can look at the periodic table and figure this out. But for convenience, it's usually nice to write that in your symbol as well. So the mass number goes on the top left, the atomic number goes on the bottom left. So I now want to look at a couple of examples and talk about how to name isotopes and then how to tell how many protons, neutrons are in each isotope. Now, hydrogen is hugely important in dealing with nuclear reactions, and it's so important that different isotopes of hydrogen get their own specific name that do not follow our systematic naming rules. Here are three isotopes of hydrogen. Notice we can tell they're all hydrogen because they all have one proton. What's different about them, what makes them isotopes, is they have different numbers of neutrons. This one has no neutrons, this one has one, this one has two. Now the specific names for these, if it just has a proton, is protium. If it has a proton and a neutron, two things, it's deuterium. If it has a proton and two neutrons, three things, it is tritium. That's not usually the way we're going to name things, though. Those are specific names that just apply to hydrogen. The way we are going to name our isotopes is we're going to write the name of the element, hydrogen, dash, and then we are going to put the mass number. So this has a mass of 1. So this isotope is hydrogen 1. This next isotope, deuterium, is still hydrogen, but since it has a proton and a neutron, it has a mass of 2. So we will call it hydrogen 2. This third isotope, tritium, is still hydrogen, but it has 3 nucleons. It has a mass of 3, so we call that hydrogen 3. So in our systematic naming, we tell the name of the atom, and then we tell the mass number, and that specifies what kind of isotope it is. If you know the type of isotope, you should be able to write the symbol, and then you ought to be able to use that symbol to tell some things about the atom. So let's do a quick example or two. Here is an isotope. It is an isotope of carbon. It's called carbon 12. So if you go to your periodic table, you can find the symbol for carbon is C. 12 is the mass number. It goes on the top left. Really, that is sufficient to specify the symbol for the isotope. But for convenience, we usually put the atomic number on the bottom left. Go back to your periodic table, look until you find carbon, and you will find that carbon has an atomic number of 6. So this is the symbol for carbon 12. The symbol for carbon 14, almost the same. The only difference is it has a different mass. So the mass number is 14, the atomic number is still 6. Two other examples. We're going to use uranium. Uranium has an atomic number of 92. You can find that by finding uranium on your periodic table. So uranium-235 has a mass of 235 and an atomic number of 92. Uranium-238, still uranium, has a mass of 238. Since it's still uranium, it still has an atomic number of 92. Now, if you understand what these numbers mean, you can tell us something about each isotope. And what you should be able to use these numbers to tell are the number of protons and the number of neutrons in the isotope. Well, the number of protons is really easy. Remember, the atomic number tells us the number of protons. Carbon has an atomic number of 6, so it has 6 protons. This is still carbon. It still has an atomic number of 6. It still has 6 protons. Uranium has an atomic number of 92, so both of these have 92 protons. The neutrons are a little bit more difficult, but they're not very difficult. Remember that the mass number tells us the number of protons and neutrons combined, the number of nucleons. So if we have the protons and neutrons, and we just want the neutrons, we need to take away the protons. So what we do to find the number of neutrons is we subtract these. So the number of neutrons in carbon 12 is 12 minus 6, 6 neutrons. The number of neutrons in carbon 14 is 14 minus 6, 14 minus 6, that's 8 neutrons. To find the number of neutrons in uranium-235, we subtract 235 minus 92, 143 neutrons. To find the number of neutrons in uranium-238, we just subtract 238 minus 92, 146 neutrons. So get used to seeing symbols for atoms, but also get used to seeing symbols for isotopes. To write the symbol for an isotope, we show the symbol for the atom, we show the mass number on the top left, and the atomic number on the bottom left.